Hi, in this video I will talk about quantum teleportation. According to no-cloning theorem, it is not possible to copy the exact state of a qubit to another qubit, but there are ways of transferring the state to another qubit. In this video, we will look at the example of how to do this. According to the quantum teleportation protocol, you need a 2-qubit system that is composed of 2 entangled qubits. Here we denote our state to be teleported as V, and we say that Asya and Balvis are sharing a 2-qubit entangled system. We can write this system in this form. Then Asya applies a CNAT gate and then a Hadamard gate to his qubits. In the end, we get the form as you see here. If we look into the details of this form, you will notice that when we have the 0, 0 here, we have the exact state. And for the 0, 1 case, we have the reversed. And for the others, we have some other combinations. So now, by using this information, we are able to obtain the state back. For details of this protocol, you can refer to Nielsen's book. So now, let's implement this algorithm. We are going to use 3 qubits and the state vector simulator. We need the state vector simulator to confirm that we successfully reconstructed our states in the 3rd qubit. We start by choosing a random angle, and we are going to encode this information to the 1st qubit. By using the RY gate, we rotate our 1st qubit to encode the angle information. Then we run the state vector simulator to see if we encoded the state correctly. After successfully encoding our states, we are ready to create the entangled states and run the quantum teleportation protocol. We create the entangled states by applying a Hadamard and a CNAT gate on the 1st and the 2nd qubits. Then Asya applied a CNAT and then a Hadamard gate to her qubits, which are the 0th and the 1st qubits. Then she takes measurements on these qubits and reports these results to Balvis. Balvis uses this information to apply an X or a Z gate. If the result of the C1 register is 1, the X gate is applied. If the result of the C0 register is 1, the Z gate is applied. Then we run the state vector simulator one more time to observe the final state, and we print the results. Let's see our results. Here, we picked an angle of 74 degrees. The teleported state is printed here, and the result of the state vector simulator is listed here. According to these numbers, it looks like we have successfully recreated our states. Now, what we need to do is to teleport this state to the 3rd qubit. We apply the quantum teleportation protocol. Here, we got a measurement of 1, 0, but we should be careful here, because the values printed here are in reverse order compared to here. So, a 1, 0 measurement here would mean a 0 and 1 result. Now, we can see in the final state 0 and 1 results as we measured here, and we can see that we have successfully teleported the state to the last qubits from the 1st qubits. For more details, you can refer to Nielsen's book.